A tank crew more afraid of their own reverse gear than enemy fire. Armor thinner than an armored personnel carrier. Foam packed inside the hull for buoyancy. That turned into a death trap the moment a shell hit. No stabilizer on the main gun, meaning it couldn't fire on the move. 10 seconds to escape after a single shot. Enough time for the enemy to unload dozens of rounds. A humiliating failure in the deserts of India. 30 years in service, not a single real battle. Nicknamed Wolverine by command, nicknamed something far crueler by its own crews. Stay till the end to find out why. August 25, 1975. The Bundeswehr adopts the first production Leopard 1A1, a vehicle weighing almost 42 tons with the L7100 5mm cannon capable of penetrating the armor of any Soviet tank of the time at a distance of 2,000 meters. In that same year, 1,000 kilometers to the north, the Swedish army puts into service its own combat vehicle. It weighs 2.5 times less than the German monster, just 16.3 tons. Its 90mm gun looks modest next to its German neighbor. But there is one detail that the German tank fundamentally cannot do. The Swedish vehicle can drive into a lake and continue moving on water without a single minute of preparation. Its name is long and hard to pronounce. Infanteriekanonwagen 91, abbreviated IKV 91. In Sweden itself, it was nicknamed the Wolverine, in Swedish Järven, after the predator that lives in the country's northern forests and is known for its ferocity and elusiveness. Hägglunds built 212 of these vehicles over 3 years, from 1975 to 1978. The crew numbered 4: driver mechanic, gunner, commander, and loader. The Volvo Penta TD120A engine, producing 330 horsepower, propelled this steel amphibian on highways up to 65 kilometers per hour. On paper, everything looked as though the Swedes had found the ideal balance between firepower, speed, and versatility. Military historians still argue about this vehicle. Some call it a brilliant engineering solution ahead of its time. Others call it the greatest embarrassment of European tank building in the second half of the 20th century. And surprisingly, both sides are right at the same time. The thing is, for 16 tons of modest weight and the ability to cross rivers and lakes without any preparation, Sweden had to pay a terrible price. What exactly will become clear a little later. For now, suffice it to say one thing. While West Germany staked its bet on frontal armor and gunpowder, banking on a direct confrontation with Soviet tank armadas, Sweden chose a completely different philosophy of war. Speed over protection. Cunning over strength. The tank must appear where it is not expected, fire once, and disappear before the enemy can respond.
It sounds like the ideal tactic of guerrilla warfare on armored vehicles, and to some extent that was indeed the original intention. But between the beautiful concept on paper and its embodiment in metal lay a chasm into which dozens of engineering solutions fell. Thin armor, an unstabilized gun, weak reverse speed. Every detail of this vehicle was a product of harsh compromise. And the most curious thing here is that each of these compromises individually had its own logic, its own explanation, its own reason. The problem began when all these compromises were added together in one 16-ton box on tracks. For exactly 30 years, this vehicle remained in Swedish Army service. 212 hulls, produced in just 3 years, served longer than many heavy tanks of the same period.
They were never immediately replaced. The army delayed modernizing its fleet until the 2000s, when they were superseded by licensed German Leopard 2s under the Swedish designation Stridsvagn 122. So we get a strange picture. The vehicle was criticized, laughed at, called an error of engineering thought, and yet kept in service for 3 full decades. How did that happen? Why did a piece of equipment that many experts considered a compromise on the brink of failure remain in service longer than some far more advanced combat vehicles of its time? The answer lies at the very beginning of the story, in the tasks that the Swedish military command set for its engineers back in the early 1960s. To understand how a country with one of the world's best engineering schools created a vehicle that is simultaneously called both a predator and a disgrace, one must return to the origins of this project. To that very era when Soviet tank columns seemed like an unstoppable avalanche, and little neutral Sweden sought its own special way to protect thousands of kilometers of forests, swamps, and lakes on its own territory. In the early 1960s, the Swedish army faced a problem that threatened to turn into a real catastrophe in the event of an actual invasion. The backbone of the infantry's anti-tank units consisted of vehicles from the Second World War era, obsolete Stridsvagn M/43 and self-propelled guns IKV-102 and IKV-103. The armor of these veterans could no longer even withstand medium-high explosive fragmentation shells, and their 75mm guns were powerless against the new Soviet T-54 and T-55 tanks, which by then were being mass-delivered to Warsaw Pact countries. Over 300 units of outdated equipment needed to be replaced with something fundamentally new, and the small Scandinavian country had catastrophically little money for it. In 1964, the Swedish Defence Materiel Administration, known as FMV, formulated a technical specification under the codename IKVM/NY, literally New Infantry Gun. The task sounded almost impossible: to create a single platform that would replace 3 obsolete types of combat vehicles at once, cost significantly less than a full-fledged main battle tank, and at the same time be able to stand on equal footing against Soviet armored vehicles. 3 Swedish companies were brought in for development, but in the end, Hägglunds, the same company that had shortly before created the PBV-302 armored personnel carrier, received the contract to build prototypes. It was precisely the units and assemblies of that APC that formed the basis of the future IKV-91. The Swedes saved money on literally everything, standardizing the transmission, running gear elements, and even part of the electrical equipment to reduce production costs and simplify spare parts supply.
Sweden officially adhered to a policy of neutrality, but the country's geography dictated its own harsh terms of the game. The only real direction of potential invasion remained the north, through Finland or the Norwegian coast, straight into Norland, with its countless lakes, rivers, coniferous forests, and marshy tundra. No classic heavy tank weighing 40 or 50 tons could physically maneuver in such terrain year-round. In spring and autumn, the swamps turned Norland into an impassable morass, and there were catastrophically few bridges capable of supporting a multi-ton behemoth. Swedish generals understood that a classic armored fist was useless here. What was needed was a light, mobile, amphibious vehicle capable of crossing water obstacles without pontoons or ferries, blending among the trees and delivering surprise attacks on the flanks of an advancing column. The first 3 prototypes of the new vehicle were assembled by the end of 1969.
Testing lasted 5 years, an unprecedentedly long time for a vehicle of this class. But every month of these trials revealed new problems with weight distribution, hull watertightness, and reserve buoyancy. Only in 1972 did the military administration approve the final design and order a series of 200 vehicles. The official name came from a simple system. The word Infanteriekanonvagn meant infantry gun carriage, and the number 91 was decoded quite logically. The 9 indicated the 90mm gun caliber, and the 1 signified that this was the first vehicle of this class with a gun of that caliber adopted by the Swedish Army. The idea looked truly revolutionary for its time. 12 such vehicles were organized into a company, and such a company was attached to an infantry brigade as a mobile anti-tank reserve.
According to the Swedish command's concept, upon detecting an advancing enemy column, the crews were to swim across the nearest lake, approach the enemy flank or rear, fire several aimed shots at the most vulnerable vehicles, fuel tankers, command tanks, repair workshops, and immediately withdraw back into the water, where the enemy physically could not pursue them. The tactic of an ambush strike followed by retreat through water turned an ordinary lake from a natural obstacle into both a safe haven and an escape route. To make this tactic work at all, the engineers had to solve a problem that, on such a scale, had hardly been encountered before in global tank building. A vehicle weighing 16.3 tons had to stay afloat without any crew preparation. No inflatable pontoons, no detachable screens, no lengthy sealing of hatches. For comparison, the Soviet PT-76 amphibious tank weighed just over 14 tons, but carried significantly weaker armament and almost no armor.
The Swedes, however, wanted a vehicle with a full-fledged anti-tank gun that could swim on its own without auxiliary means. This requirement determined literally every engineering decision in the design of the future IKV-91. From hull shape to armor thickness, from engine placement to ammunition stowage. And it was precisely from this requirement that the main drama of the entire vehicle's history grew. Because, for the sake of extra centimeters of buoyancy margin, the designers had to make concessions in the most sensitive area: the weapon system and crew protection. Formerly, the IKV-91 was considered a tank destroyer, a defensive vehicle whose task was to hit enemy armored vehicles and preserve its own crew. But in fact, from the point of view of international classification, this vehicle much more resembled a light tank, with a rotating turret, a full 4-man crew, and fairly versatile armament. That is exactly how it was later marketed on the international market in the late 1970s and early 1980s, when the Swedes tried to find foreign buyers for their unusual development. How successful that attempt turned out to be is a separate and rather dramatic story. But for now, in the mid-1970s, the main challenge for the new vehicle was not the foreign market, but its own gun, around which one of the most serious internal disputes in the history of Swedish tank building erupted. The gun mounted in the IKV-91's turret was called the Bofors KV-90 S73, a rifled 90mm cannon with a barrel length of 54 calibers. On paper, the characteristics looked quite respectable for a vehicle of such modest weight. The ammunition load comprised 59 rounds of unitary loading, of which 13 were located directly in the turret's fighting compartment for quick access, while the remaining 46 were stored in the hull next to the driver mechanic's position. The primary anti-tank round was a fin-stabilized, high-explosive anti-tank heat shell weighing 4.5 kilograms, leaving the barrel at an initial velocity of 825 meters per second. According to the manufacturer's documentation, Such a round theoretically penetrated up to 400 millimeters of homogeneous steel armor, a figure that, on paper, placed the modest Swedish gun on par with far more renowned guns of that period. But here began the main feature that defined the entire subsequent combat reputation of this vehicle. The Bofors gun belonged to the class of low-impulse weapons. Essentially, it was a breech-loading system with a relatively small powder charge, designed to minimize recoil and allow this weapon to be mounted on an extremely light chassis without a powerful recoil mechanism. For comparison, the rate of fire was 8 rounds per minute with a well-coordinated crew, a figure quite comparable to heavier vehicles of the time. But the low initial velocity of the projectile produced a steep, almost mortar-like trajectory. At ranges beyond 800 meters, the gunner had to introduce such substantial vertical corrections that the target literally disappeared from the field of view of the 10 times Simrad GDAD sight. The slightest crosswind would drift the lightweight 4-kilogram shell several meters sideways, which meant that the effective engagement range against moving targets rarely exceeded 600 meters. Whereas Soviet tanks of that period could confidently hit targets at a distance of 1.5 to 2 kilometers. The coaxial machine gun KSPM/39B, the Swedish version of the legendary American Browning M1919, in 7.62 by 51 mm NATO caliber, served for sighting and engaging light vehicles and infantry. A second such machine gun was mounted on the loader's turret, but its practical combat value remained limited due to the modest vertical traverse angles of the mount itself. All these details of the gun system formed the contradictory picture. The penetration figures looked formidable, the rate of fire seemed decent, but real effectiveness in dynamic tank combat ran up against ballistics that were designed more for static defense from an ambush than for maneuvering confrontation with modern tank columns. And that was only the beginning of the compromises the designers had to make for the main goal: to teach a 16-ton vehicle to swim without any preparation. For the sake of that very buoyancy, the Swedish engineers had to sacrifice what is traditionally considered the foundation of foundations in tank building: armor thickness. The hull of the IKV-91 was a welded construction of rolled steel plates of variable thickness, and the most powerful part in the entire frontal projection, the lower glacis plate, had a thickness of exactly 20 millimeters, set at an angle of 30 degrees from the vertical. The upper glacis plate turned out to be even thinner, only 12 millimeters, but received an extreme angle of 70 degrees and a characteristic shape that engineers among themselves called a pike nose, a pointed profile designed to ricochet shells upon tangential impact. When recalculating the angle into effective armor thickness, the value came to about 40 to 50 millimeters of homogeneous steel, a figure sufficient to protect against heavy machine guns like the American Browning M2, but which provided no defense whatsoever against specialized anti-tank weapons. Any Soviet heavy machine gun, like the KPVT of 14.5mm caliber, would punch through this construction at over a kilometer's distance. The frontal part of the turret was even more weakly protected. The gun mantlet itself, of a complex wedge shape, had a thickness of only 8 millimeters, behind which was mounted an additional protective screen 12 millimeters thick. Due to the smoothly rounded, streamlined shape of the turret, designed again to minimize weight and improve hydrodynamics on water, there was no solid frontal plate in the conventional sense. The roof and sides smoothly flowed into the gun mantlet, creating extensive zones where the effective armor thickness barely reached 15 millimeters.
The side and rear projections represented a classic example of armor at the level of a light armored personnel carrier, rather than a combat vehicle intended to meet enemy tanks. The thickness of the side plates varied from 14 mm in the upper part of the hull to 8 mm in the running gear area. To compensate for the necessary reserve buoyancy, Hägglund's engineers filled the internal cavities between the outer and inner armor layers with ordinary polyurethane foam, a solution ingenious in its own way since it did reduce the overall specific weight of the hull and added additional displaced water volume.
But this solution had a very unpleasant side effect. Against a shaped charge projectile, the foam worked almost as a conductor, helping the hot jet of explosion products pass through the porous structure even deeper into the fighting compartment, rather than dissipating its energy. In the event of a hit to the side by a Soviet heat round like PG-9V, the crew's chances of remaining unharmed inside this 16-ton box approached zero. The vehicle's layout added its own share of vulnerability. The driver's compartment was located front left, the turret was shifted closer to the rear, and the massive 6-cylinder Volvo Penta diesel engine, already mentioned, was installed in the rear of the hull at an angle of 32 degrees to the vehicle's longitudinal axis. The designers adopted this inclination solely to save silhouette height, reducing the tank's overall profile and facilitating its camouflage among the low Scandinavian brushwood. This technical solution had its own downside. Upon a hit to the rear armor plate, the engine would be torn from its mounts, and the drive shaft running from it to the Allison automatic transmission would turn into a giant steel ram capable of piercing the fireproof bulkhead and entering the driver's workspace. The vehicle's suspension was built on 6 rubberized road wheels per side with individual torsion bars, and the wide track of 440 mm provided a ground pressure of only 0.7 kilograms per square centimeter, a parameter that allowed the vehicle to virtually glide over loose snow and marshy soil without sinking where far heavier tanks would bog down. However, this lightness had another, far more dangerous weakness, which directly concerned not protection, but the vehicle's behavior at the most critical moment of battle. The moment of firing. The Bofors KV-90 S-73 gun had no stabilization system whatsoever, neither in the horizontal nor vertical plane. By the end of the 1970s, the Soviet Union was mass-equipping its tanks with 2 plane stabilizers, allowing aimed fire on the move without stopping the vehicle. Swedish technology, in this sense, remained a product of an earlier technical era. To make an accurate shot, the driver-mechanic had to bring the vehicle to a complete stop, wait for the longitudinal and transverse hull oscillations to subside, and only then could the gunner take an aimed shot. This entire process, from full stop to the moment of pulling the trigger, took between 1.5 to 2 seconds, during which the tank stood absolutely still, presenting an ideal target for any enemy anti-tank system equipped with automatic tracking. An even more critical problem turned out to be reverse speed. The maximum speed in reverse was only 11.4 kilometers per hour, a figure that, in ambush tactics requiring immediate withdrawal after a shot, turned every combat episode into a dangerous ordeal. The crew would emerge from cover, stop, fire a single aimed shot, and then needed about 10 seconds to roll back behind natural terrain cover. In those 10 seconds, any enemy equipped with a small caliber automatic cannon, for example, a Soviet 30mm rapid fire mount, could fire a burst of several dozen rounds before the Swedish vehicle disappeared from sight. It was precisely the combination of the lack of gun stabilization, the need for a full stop before firing, and slow reverse speed that constituted the set of technical compromises that made ambush tactics far riskier in practice than they appeared in the theoretical staff planning of the Swedish command in the early 1970s. The Swedish military engineers and command were fully aware of their creation's weaknesses. By the early 1980s, when the Soviet Union began mass-fitting its armored vehicles with explosive reactive armor blocks like Contact, the effectiveness of Bofors heat rounds against modern tanks dropped to virtually zero. The shaped charge jet was dissipated by the external explosive screen, simply not reaching the target's main armor. It became clear that the basic version of the IKV-91 needed deep modernization or risked losing all combat value within the next decade. Thus was born the project designated IKV-91-105, an attempt to radically rethink the vehicle's combat capabilities. Hägglund's engineers took the production chassis and reinforced the torsion bar suspension shafts to handle the increased load. Instead of the original turret, they installed a full-fledged German Rheinmetall RH-105-20 design, equipped with a 105mm rifled gun, the same L7 system used on the German Leopard 1 and many other NATO tanks of the period.
The muzzle velocity of the new gun's armor-piercing, fin-stabilized discarding sabot APF-SDS round reached 1,450 meters per second, almost double that of the original 90mm gun. The vehicle's weight increased to 18 tons, but in return, it finally received a full two-plane gun stabilizer, allowing aimed fire on the move, as well as a modern thermal imaging sighting channel, completely absent on the basic version. The rate of fire increased to 8 rounds per minute, thanks to a more spacious and convenient fighting compartment, although the ammunition load had to be reduced to 50 rounds due to the larger dimensions of the new ammunition. To compensate for the inevitable loss of buoyancy due to increased weight, the designers applied a solution not present on the basic model. At the rear of the export version, they installed 2 propellers in annular protective nozzles, completely replacing the primitive system of movement by track rewinding.
While the basic IKV-91 managed a modest 6.5 kilometers per hour on water, the new version with propellers could reach an impressive 12 kilometers per hour afloat, and the crew could simultaneously traverse the turret and fire aimed shots right during the crossing of a water obstacle. This upgraded variant was offered by the Swedes on the international arms market, and the main potential buyer was India, which was seeking a replacement for its aging fleet of Soviet PT-76 amphibious tanks. In 1983, the single prototype of the IKV-91-105 was sent for comparative trials to a proving ground in the Rajasthan desert, where the Swedish vehicle was to compete with the French competitor AMX-10P. The test conditions proved merciless for the Scandinavian technology. Extreme heat, fine abrasive dust clogging the cooling system, and a complete absence of the humid coolness to which Sweden was accustomed.
The TD120A engine's cooling system, originally designed for a temperate northern climate, regularly overheated and became clogged with sand within just a few hours of operation. The gun's depression angle of -10 degrees, quite adequate for firing on Sweden's flat terrain, proved insufficient for engaging targets from the reverse slopes of India's hilly relief. After a series of grueling tests, including firing on the move and crossing muddy sections, The Indian side politely declined the purchase of a batch of 40 vehicles, citing excessive complexity in maintaining Volvo Penta hydraulic systems and the near-total absence of necessary spare parts in the region. This export failure effectively put an end to further development of the modernized version. The IKV 91-105 prototype returned home, sat for several years in Hägglunds hangars without moving, and was eventually sent for scrapping along with its remaining components and assemblies, never having seen series production.
The basic version of the vehicle, despite all its identified shortcomings, continued to serve in the Swedish Army for nearly another 2 decades. The Army simply lacked sufficient funds for a mass replacement of the 212 built vehicles, and the IKV-91 remained the backbone of light anti-tank units right up until the end of the 20th century. The only notable improvement that the basic vehicles did receive over their long service life was the installation of a twin-barrel 70mm Bofors Lyran grenade launcher on the sides of the turret, designed to fire illuminating flares weighing about 1 kilogram, an important addition for night fighting under the Scandinavian polar night. The vehicles were also equipped with a smoke grenade launcher system, delivering a salvo of 6 charges and creating a dense, impenetrable screen for about 20 seconds. Just enough time for the crew to withdraw on their slow reverse gear. In the 1990s, Swedish engineers considered installing an American TOW anti-tank missile system in place of the traditional gun turret. But preliminary calculations showed that the launch tube's recoil would surely damage the fragile mountings of the turret ring, which had never been designed for such loads. The final chapter in the IKV-91's history was written in 2002. By that time, the Swedish Army had completed the procurement and fielding of modern heavy tanks, the Stridsvagn 122. The licensed Swedish version of the German Leopard 2 A5, a vehicle of an entirely different generation with composite armor, an automatic target tracker, and a full thermal imaging fire control system. All 212 built IKV-91s were officially retired. Some of the hulls were turned into targets at the Karlsborg firing range, where they were methodically shot up by 40mm rapid-fire cannons of CV-90 combat vehicles, testing new types of armor-piercing ammunition. Others went to museums across the country, and several dozen hulls, surprisingly, found a second life. Years after decommissioning, they were refurbished and transferred to the African country of Congo under a military aid program, where these 16-ton vehicles continued their service in completely different climatic conditions, far from their native Swedish lakes and forests. 30 years of service, not a single actual combat engagement, a failed attempt to enter the international arms market, and a reputation as a vehicle that became a symbol of what happens when one tries to sit on several chairs at once. That was the outcome with which the story of the Swedish Wolverine ended. The engineers at Hägglunds tried to build simultaneously a light reconnaissance vehicle, a swimming amphibian, a full-fledged tank destroyer, and an affordable replacement for an obsolete military vehicle fleet. And, as 3 decades of operation showed, the attempt to combine all these requirements in one 16-ton design resulted in a vehicle that lacked the armor for a real tank battle, lacked the withdrawal speed for truly safe ambush tactics, and lacked the versatility for successful entry into the competitive international market. Sometimes, the best engineering solution is not the invention of a fundamentally new wheel, but the honest acknowledgement that not every task can be solved by a single vehicle, no matter how many brilliant compromises are built into it. If you enjoyed this story about the Swedish tank, Be sure to check out other videos on our channel about the most unusual and controversial pieces of military equipment. Links to them will appear right now on the screen.